one more example. Let's see how far can we stretch this shortcut or approach. So I say 2x minus 1 less than equal to 7. Will the method work? 7 into 214 plus 115, is that the answer? So let's first of all work this out. I think we have looked at solving this kind of an equation or inequality earlier also, but let's just do it a couple of more times using different methods as such, right? So one approach, a basic level approach would be, instead of a 2x, call it a r or call it some variable. So you have a r minus 1 less than equal to 7. And then quickly go into your numbers story. The reference point is 1. The distance of r from 1 can be up to 7. So go 7 in this direction, you will get 8. Go 7 in this direction and you will get a minus 6. So great. R range can be very clear. R is greater than minus 6 and less than 8. Put the equal sign everywhere because we have an equal sign here. So I've got the value of R, but R actually is 2x. Love it. 2x. So divide everything by 2 and I'll get a minus 3. Divide everything by 2 and you will get minus 3, 4x, and the inequality will remain exactly the same because you're just multiplying by 1 by 2, which is a positive number. Notice how in every question, every step, I'm repeating the core ideas again and again. You should do the same. So now I have the range of x actually, and x is going to be between minus 3 and 4, and now I can count also. Minus 3, that means 3 solutions on the negative side, plus 4, that means 4 solutions on the positive side, 4 and 3, 7, and the 0 will also work, so total 8 solutions. So that 2 into 7 plus 1 logic is not working for me anymore. And why is that happening? Because now in the story there is a coefficient of 2. So obviously I should try one more example to see is it 7 plus 1 8 if the coefficient is 2? Maybe is there a game like that? Not that it is needed. You solved it using this and you got the range, then you can manually count. There should not be a problem at all. This shortcut is for easy problems anyway, right? So that was one approach. Same question, 2x minus 1 is less than equal to 7. And this time I'm going for calling all of it just a big capital P. So capital P is less than equal to 7, which tells me P is greater than equal to minus 7 and less than equal to 7. Now instead of a P, I will put the whole thing. Remember, 2x minus 1 is P. So I will say 2x minus 1 in the middle and 7 and minus 7 on each side. I want to get rid of the minus 7, that means add 1 everywhere. So this will become 8 and this will become minus 6. And as you do this, and especially if you're doing it yourself, thinking along, you'll see, okay, we're getting to the same point. Finally, x is greater than equal to minus 3 and less than equal to 4. And now once again I can count the solutions manually. Of course, I can also do this question by creating two stories. One is positive, one is negative, and then just going for the equation. So basically now we're in the having fun territory, just playing with the data. But overall my number of solutions is still 8. We have not explored the connection between the coefficient and the number of solution yet. I'm just saying that even if a new situation is given where no shortcut is working, do I have enough tools to work it out and reasonably quickly? Yes. The second layer of speed can be added simply by practice. The more you have done, the faster the recall, the better your response time, right? Let's play. Just change the story. 2x minus 3 is less than equal to 9, let's say. Right? So I will go for the capital approach. I'll just call it capital R. Capital R is less than equal to 9. That means R is greater than equal to minus 9 and it is less than equal to 9. I am going for one approach, maybe you should try another, right? So R is greater than minus 9, less than equal to 9. And now instead of R, I can put a 2x minus 3. Now I can get rid of the 3. I will add a plus 3 in the story, so this 3 will go away. I will add a plus 3 in the story, so I will get a minus 6. I will add a plus 3 in the story, so I will get a 12. Now I will divide everything by 2, so I will get a x is greater than equal to minus 3 and it is less than equal to 6. How many solutions? 3 on this side, 6 on this side. That means 3 on the negative realm, 6 on the positive realm, total 9 and a 0 in between. the total number of solutions is 10. So once again, the final answer is just this. But now, is it true for any coefficient of x, or is this story working only for 2, right? Because the x is getting divided. Or is this story only working for coefficient 2? And how will I figure that out? Now it's not about this problem. Now onwards, how many formulas will you remember, right? So this is enough of an insight that I could have come to this point quickly and then this point quickly. Even that is a good speed escalator, right? But just for fun and just to drive home the process of how does or how do I figure all of this out, I just sit and play with it, and after a while things come out, right? Though some of it I don't recommend, because some of it comes after a lot of playing and you might not have a lot of time, you might have only a limited time to master core ideas, and that's why the core ideas are way more important than the jugglery as such. So at this point of on you can create your own questions with your own values. You're just playing with it because the method is repetitive. Less than equal to 8, let's say. I will just call it a capital alpha, and this capital alpha is less than equal to 8. So that means this alpha is greater than minus 8, it is less than 8. Notice after you know the process, it almost becomes meditative. You just have to take step by step, do not think about the world, nothing bothers you, only the next step. Now instead of the alpha, I'll put a 3x minus 2. To get rid of the minus 2, I'll add a plus 2, I'll add a plus 2, this will become a minus 6. I will add a plus 2, this will become a 10. I will divide everything by 3. What will I get? Minus 2, I will get an x, and I will get a 3.33. So this time your range is from minus 2 to 3.33. Let's think about that. So you have a 0, you have a minus 2, you have a minus 1, and you have a 1 and a 2 and a 3, right? 1, 2 and a 3. Because the 0.33 is not going to be an integer. So how many integers? 3 on this side, 2, 5 on this side, 3 on this side, plus 2 on this side, a total of 5, and a 0. That means our total integral solutions are 6. Now what connection can I find, right? So I would not, I can start analyzing and find a pattern here, but I would not recommend doing it, because even this is reasonably good enough. And if there is no coefficient, definitely you can go for a lot of speed, right? So just a little bit of extra playing with the modulus of linear equation level and combining it with inequalities, and then looking at some maybe time saving experiences. You know the range is going to be between these 2 points, especially when there is a less than equal to sign involved. When it is greater, then it is going to be beyond those 2 points, and how to connect all of this together.